Physical Science Chapter 9 has 2 videos. The first video for each section will have the note packet that you have in front of you. The second video you will need for other information to be prepared for pop quizzes, for your tests, etc. I just think it's a better set of notes than what the company now provides, and thankfully I still have a video on that. So this for your actual notes. Feel free to write anything down from the other video, although it is not required, just this one. And I guess that's it. So Chapter 9, Physical Science, Introduction to Waves. The big idea is waves transfer energy from place to place without transferring matter. All of the sections for this chapter will be included on this single video. So sections 1, 2, and 3 will be on one video. Section 1, the nature of waves. Essential questions: how do waves transfer energy? What are mechanical waves? And how do transverse waves differ from longitudinal waves? And again, for a better description, really take a look. I highly suggest to you look at the individual videos for each of these sections that are included on my YouTube channel. The disturbance travels outward from the spot where the pebble splashed. The pebble produced a small wave in the pond, and a wave is known as a repeating disturbance that transfers energy through matter or space. Other examples of waves include ocean waves, sound waves, seismic waves, and light waves. Because a falling pebble is moving, the falling pebble has kinetic energy. As the falling pebble splashes into the pool, as in the figure on the previous screen, the pebble transfers some of its energy to nearby water molecules, causing them to move. Those molecules then pass the energy along to neighboring water molecules, which, in turn, transfer it to their neighbors. The energy travels farther and farther from the source of the disturbance. However, the water itself does not move outward. What you see is energy traveling in the form of a wave on the surface of the water. Sound waves travel through the air to reach your ears. Ocean waves travel through water to reach the shore. A medium is matter through which a wave travels. The medium can be a solid, a liquid, a gas, or a combination. Not all waves need a medium. Some waves, such as light and radio waves, can travel through a vacuum, also known as outer space. Mechanical waves, such as sound waves, are waves that can travel only through matter. At this point, you will want to pause the video and go take a look at PS.9.1. Come back to this video later for section 2. So if you're looking at it now, you have already did section 1 for your notes, and you have viewed PS 9.1 for additional learning material. That will be important for the success of your quizzes, your tests, and the chapter as a whole. So section 2 is all about wave properties. How are wavelength and period related? What is the relationship between frequency and wavelength? And I'm going to tell you now, people confuse this all the time. You'll want to get it straight because it's not going away. How do you calculate speed of a wave? Waves can differ in how much energy they carry and in how fast they travel. Waves also have other characteristics that make them different from each other. Suppose you shake the end of a rope and make a transverse wave. The transverse wave in the figure below has alternating high points and low points. Crests are the high points of a transverse wave, and troughs are the low points of a transverse wave. The imaginary line, seen here in this dotted line, is the vertical distance between the crest and the trough. This is known as the rest position. All waves have wavelength. Wavelength is the distance between one point on a wave and the nearest point just like it. The figure below shows that for transverse waves, the wavelength is the distance from the crest to the other crest, or from a trough to the other trough. These two distances are equal on a transverse wave. The frequency of a wave is the number of wavelengths that pass a fixed point each second. Frequency is also the number of times that a point on a wave moves up and down or back and forth each second. You can find the frequency of a transverse wave by counting the number of crests that pass a point each second. You can find the frequency of a longitudinal wave by counting the number of compressions that pass a point each second, and we will have quite a few labs over this. The period of a wave is the amount of time it takes one wavelength to pass a point. As the frequency of a wave increases, the period decreases. In SI units, period has units of seconds. When frequency increases, the number of wavelengths that pass in 1 second also increases. Here you can see the rope is moved up and down 1 time in 1 second. The wave has a frequency of 1 hertz. In this picture, the rope is shaken down, up, and down twice in 1 second. The wave has a frequency of 2 hertz. The speed of a wave depends on the medium through which it is traveling. Sound waves usually travel faster in liquids and solids than they do in gases. However, light waves travel more slowly in liquids and solids than they do in gases or in a vacuum. Also, sound waves usually travel faster in a material if the temperature of the material is increased. For example, sound waves travel faster in air at 20 degrees Celsius than in air at 0 degrees Celsius. Amplitude is a measure of the size of the disturbance from a wave if the wave's amplitude is greater than the disturbance from the wave that is also greater. Amplitude is measured differently for longitudinal waves and transverse waves. In the figure on the next screen, the coils in the high amplitudes waves compression are closer together than the coils in the low amplitudes wave compression. So here we can see, compared to a lower amplitude, wave coils are closer together in compressions, compared to lower amplitude here, because their rarefications are farther apart. At this point, you will pause the video. I need you to check out so that you can be well prepared for this section, for the test, pop quizzes, etc. Take a look at better explanation, flip video, PS.9.2. Section 3 of Chapter 9, the behavior of waves. You should have already viewed and filled out your notes for Section 1 and Section 2 on this video. You should have also, before you hit this, gone and looked at PS.9.1 and PS.9.2. If you have not yet done that, stop the video and go do those things first. What is the law of reflection? Why do waves change direction when they travel from one material to another or one type of medium to another? How are refraction and diffraction similar, and how are they different? What happens when waves interfere with each other? If you are one of the last people to leave your school building at the end of the day, you will probably find that the hallways are quiet and empty. When you close your locker door, the sound echoes down the empty hall. Your footsteps also make a hollow sound, which is slightly creepy. Thinking you are all alone, you might be startled by your own reflection in a classroom window. The echoes and your image looking back at you from the window are caused by wave reflection. Without this, you could not even see the lockers in your school's hallway. Refraction is the bending of a wave caused by a change in its speed as it travels from one medium to another. The greater the change in speed, the more the wave bends. The top panel in the figure at the right shows how a wave refracts when it passes into the material in which the wave slows down. The wave is refracted, bent, toward the normal. The bottom panel in the figure above shows how a wave refracts when it passes into a medium in which it speeds up. Then, at that point, the wave is refracted away from the normal. Diffraction is the bending of a wave around an object. Diffraction and refraction both cause waves to bend. The difference is that refraction occurs when the waves pass through an object, while diffraction occurs when a wave passes around an object. Think of a detour. When you're driving, if you have to go around an obstacle, they send you on a detour. That's what a diffraction is. It's a detour of the waves. All waves, including water waves, sound waves, and light waves, can be diffracted. Diffraction can also cause ocean waves to change direction as they pass around an island. Interference is the process of two or more waves overlapping and combining to form a new wave. This new wave exists only while the two original waves continue to overlap. Two waves can combine through either constructive interference or destructive interference. Resonance is the process by which an object is made to vibrate by absorbing energy at its natural frequencies. Sometimes resonance can cause an object to absorb a large amount of energy. An object vibrates more and more strongly as it absorbs energy at its natural frequencies. If the object absorbs enough energy, it might break. At this time, the video is over and completed. You will need to go directly to PS 9.3 to continue your online learning.